A couple sections ago, we looked at the distributive property and understood it as rearranging boxes in a grid so that they were easier to compute. When we were looking at that section, we were only dealing with addition. We are now going to see how the distributive property interacts with subtraction. We can understand the interaction between multiplication and subtraction, or multiplication and negative numbers, by looking at pictures of grids. Consider the picture of 18 times 7. Instead of thinking about this as 18 times 7, we can turn the picture into 20 times 7 and then remove the last two columns of boxes. Algebraically, this can be communicated in a fairly straightforward manner. 18 times 7. We thought of 18 as 20 minus 2. And so we changed the 18 to 20 minus 2. Notice that we're using parentheses to keep these terms grouped together. Now we will use the distributive property. This time, instead of adding the products together, we will be subtracting. Notice how the subtraction symbol carries over from the previous line. And then from here, we simply compute. As always, the picture is serving the role of being a conceptual basis for the calculation. But in the end, we want to move towards expressing the ideas using symbols. Example, compute 20 minus 3 times 8 using the distributive property. Let's take a look at the picture. 20 minus 3 times 8 is equal to 20 times 8 minus 3 times 8. That's the very large rectangle minus the red rectangle that's been subtracted off, which is 160 minus 24, which is 136. Example, compute 30 minus 2 times 20 minus 4 using the distributive property. Your reflex should be that this is some sort of FOIL computation, but the new wrinkle in this calculation is that we have to deal with subtraction. In order to understand this, we'll first look at the picture. Notice that 28 times 16 gives the number of boxes in the top left portion of the rectangle. The right and bottom portions account for the parts that have been removed, except for the small piece in the bottom right has been removed twice. In order to obtain the correct answer, we need to add it back to account for the double removal. Algebraically, this happens automatically when performing the calculation. The added trick now is that we need to pay attention to the sign in front of the numbers in order to get the signs in the final calculation correct. Here, we are using the same rules of multiplication with negative signs as before. The first in FOIL is 30 times 20, and both are positive. 30 times 20. The outer in FOIL is 30 times 4, but there's one negative sign. So that means we're going to subtract 30 times 4. Inner is 2 times 20, but there's a negative sign in front of the 2, so that's another minus 2 times 20. And for the last, we have 2 times 4 with two negatives. A negative times a negative is a positive. So it'll be plus 2 times 4. And from here, we just work out the arithmetic. 30 times 20 is 600, minus 30 times 4 is 120, minus 2 times 20 is 40, plus 2 times 4 is 8. 600 minus 120 is 480. 480 minus 40 is 440, plus 8 is 448. It's worth taking a moment to match up the products with the appropriate pieces on the picture. 30 times 20 is the entire rectangle. 30 times 4 is the combined bottom rectangle. 2 times 20 is the combined right rectangles. 2 times 4 is a small bottom right rectangle which has been subtracted off twice, which is why we have to add it back in. And the final answer is 28 times 16, and that's the unshaded portion in the top left. Example, compute 40 plus 7 times 30 minus 4 using the distributive property. This time we have a combination of both addition and subtraction. Notice this time that there's a different set of rectangles that have been shaded in, and that these are the rectangles that correspond to the subtraction. The main trick when doing the algebra is to pay attention to the signs and go slowly. 40 plus 7 times 30 minus 4. The first in FOIL, 40 times 30, positive times positive, so it's a positive. Outer is 40 times 4 with one negative sign, so it's minus 40 times 4. The inner is 7 times 30, and both are positive, so plus 7 times 30. And the last is 7 times 4 with one negative, so minus 7 times 4. 40 times 30 is 1200, minus 40 times 4 is 160, plus 7 times 30 is 210, minus 7 times 4 is 28. 1200 minus 160 is 1040, plus 210 is 1250, minus 28 is 1222. And once again, we'll compare the products with the picture. 40 times 30 corresponds to the two rectangles on the left. 40 times 4 corresponds to the rectangle on the bottom left, which is removed. 7 times 30 are the two rectangles on the right. And 7 times 4 is the one rectangle on the bottom right that has also been removed. Having a good sense of what's going on in the pictures can be helpful when thinking through calculations. It also helps to build your geometric intuition, which can be helpful in many practical situations.